So welcome back, ladies and gentlemen. This part of the lesson is on inverse functions. And you have the handout, hopefully, and you can read the definition. But honestly, long story short, if you remember how I introduced functions to you, input, outputs, the definition of inverse is really this. Let's see if someone actually fall from the example I'm going to give you made up. If we have a point 2, -3, and if we wanted to do the inverse operation, no pressure, can someone tell me what should I write as the transformation? And if you look what I wrote, x, y, arrow, y, then x. Saba?
-3 then 2.
Nice! So a lot of you understand innately, it's just a swapping of the x and y coordinates. That's really what inverse is. At its heart, this is super easy. Super easy. Everyone okay with that? So another example here really quickly. Let's give you a set notation of just 2 sets. So this is the function, and I want to do an inverse operation. I'll just put an S inverse. Can I get a volunteer to give us the answer? Again, that's 2, 1 and -4, 1. What is the inverse of that? Flora!
1, 2, and 1, -4.
Is correct. Let's just do a recap of what we were teaching you all along at the beginning of this year. The first set, the 2, 1, and the -4, 1. Is this a function? Yes or no? 50-50 chance, ladies and gentlemen. Function, yes or no? Grace is doing this. It is a function, right? For every input, there's one output. So this is the function. My next question, I think a lot of you are understanding. When Flora did the inverse, this is correct. My question to you, is this a function? Yes or no? Danielle's shaking her head. This is not a function. So ladies and gentlemen at home, although we understand the transformation of inverse, just to make sure we're clear, not all inverses are functions. They may or may not be, and that's key. The symbol that we use, or the notation we use, is going to look weird, but it's going to make sense. This is the symbol for inverse, f to the -1. So we don't say f to the -1. This in English says inverse, so I'll write that a little bit larger. Inverse of whatever. So technically, I should have written this as this, s to the -1, but that just means inverse. Technically, if the inverse is not a function, I am actually not supposed to write this. I'm just supposed to say the new function, or the new relation is blah, 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 blah. Because this is only for inverse functions, but that's the notation that we have that really represents what we're given. So how do we find the equation of an inverse function? We'll do 2 examples. We'll do a linear one, and then we'll do a quadratic one. It's really easy. So notice for the linear one, let's say y equals 2x plus 1. This is clearly a function. It's a straight line. It has a slope of 2, has a y-intercept of 1. Right? We can also graph it and everything, and maybe we should. I'm just going to be sketching this out. So at 1, there we go. It looks something like this. Right? And I apologize, it's actually better at home. And if you follow the handout, it will reinforce this, or the PowerPoint. But y equals 2x plus 1. How to find the equation of the inverse? Well, what we can do is follow fundamentally what we've done at the beginning. And a lot of you already understand this. We swap the x's and y's. Now some students say, Mr. Chen, why don't we just write this out? What's the big deal? Why can't we write this out? Well, this is just bad form, right? So even though you could technically go to Desmos in GeoGebra and write this equation out, which kind of makes sense, this is the inverse. We still solve for y. So how do I solve for y? Subtract 1 to both sides. And then divide both sides by 2. So we get y is equal to half x minus a half. And if I were to rewrite this, the inverse is this equation. That's all it is. Let's just pause here for a second. Not the video at home, but let's just make sure we're okay. Notice what I'm going to do though. I'm going to kind of sketch this out so you guys can see it. This means it has a slope of 1/2. So unlike the original one, rises 2, runs 1. This example, rises 1, runs 2. And its y-intercept is not positive, it's -1/2. So -1 is maybe down here. And it looks something like this. So this is the inverse, and this is the original. And some of you may or may not see it because I know I'm just sketching here. Anyone see anything interesting between the white line and the red line? And if you don't see it, just tilt your head 45 degrees. Anyone see anything interesting? Flora.
It feels like it's reflected.
It is reflected, and it's reflected actually across this line, which is y equals x. So another attribute of this function, all inverses are reflections across the y equals x line. Which is kind of neat. And that's why when I taught you this lesson, way back on transformations of functions, this is really the first function, which is not included in our package because it's kind of silly. I'm going to erase this chalkboard, but we need to do the second example with the quadratic. Is that okay? We'll do it over here. And we'll do it actually in vertex form, if that's okay. So y is equal to, our second example of how to find the equation of the inverse, y equals, let's do it like this, x minus 1 squared minus 4. So let's say that's our function. Everyone okay? That's fine. I should make something easier. I don't know. Just want to make it a little more interesting. So this is our original function. So how can I find the inverse for this? Well, I think everyone agrees. We'll use blue chalk just to stress it. We'll swap. Oops, I moved it. Did I move that?
I moved it.
That was Maria, ladies and gentlemen. It's all good. So we swap the x's and y's, correct? So x is going to go here. Y is going to go here. And again, some students say, well, why can't we just enter this in? Like it looks good. What's the big deal? Well, we have to solve for y. So any volunteer want to start us off? What do you think we should do first? So?
Add 4 to both sides.
Nice. So we get x plus 4 is equal to 2 times y minus 1 squared. What should we do next? So again.
Divide by 2.
Nice. So is it okay that we just do it this way? We'll do 1/2 x plus 4 is equal to y minus 1 squared. We're almost there. 2 more steps to do. Sava's taking the lead. Go ahead, kiddo.
You square and add.
Square both sides. Let's emphasize this in orange chalk. if we square both sides, which is correct, we'll get y minus 1 over here. You know what? Let's move this over. I apologize. People at home, if you're watching, just to make sure, so you can see it at home easier. So we're going to get the square root of 1/2 x plus 4 is equal to y minus 1. But I think a lot of you realize we're going to get a plus and minus. And finally, so
Add 1 to both sides.
so a final answer, therefore, the equation is y is equal to plus or minus the square root of 1/2 x plus 4 plus 1. And notice, this is actually not one, but two answers. So let's, even though this is actually hard to do, let's take the original function. Is that okay? We'll take the original function and we'll just sketch out the parabola. So the original function, some of you are obviously realizing why I'm pausing. Notice I did not put the inverse function here because it's technically not, a lot of reading kind of leads, this is not a function. Y equals 2 times x minus 1 squared minus 4 is at 1 and negative 4. And I don't know where the roots are, who cares, but it looks something maybe like this, maybe. It might actually go to 0, 0. Is that right? 0. No. When x is 0. Sorry, when y is 0. Whatever, I don't want to do it. So it looks something like that, right? Everyone agree? And some of you already know that coordinate is 1 and negative 4. So a lot of you can tell from this version, this is like the P and the Q, right? Now, don't get me wrong, if you don't want to think about that, ladies and gentlemen, in class or at home, negative 4 and 1, where is the inverse point? Well, negative 4 and 1 would be 1 and negative 4, right? No, sorry, what did I say? Negative 4 and 1. So negative 4 and 1 is here. Right? And the positive one, hope everyone's following along. The positive one is going to be this side. And the yellow one is going to be this one. And just to do a summary over here really quickly, it looks something like this, right? People at home or in class, it looks like this, something. If we do the vertical line test, it fails, right? Everyone agree? And that's why I'm trying to illustrate. Unlike the straight line, this one here, where the inverse was a function, if we do the vertical line test for the red line, it satisfies. But for this one, the quadratic, it doesn't, right? Because it doesn't work there. Let's just pause here. Any questions of what I'm showing you before we get to the final concept here about inverse? So the whole reason why we're doing this, and let's just slide this over. Restricting the domain of the original function, even though the quadratic that we kind of did as an example, it's not a function, we can still make it a function by restricting the domain of the original function. What does that really mean? I'll use this graph here. If we just take this region, and notice I think some of you are actually understanding it. This is the positive side from 1. Everyone agree? So positive side. So if I restrict the domain of the original parabola, this side only, at 1 onwards, it would correspond only to this answer. And if I were to ask you, is the orange thing a function? The answer would be probably like this. It looks like a root function. That's why, again, one more time, when we were teaching you the root function to graph, some of you said, or maybe some of you thought, it looks like a sideways parabola, but the sideways parabola is not a function. Right? It's a combination of both the root functions. So to answer this, restrict the domain of the original function. There's actually an infinite number of answers, but we want the optimal answer, and a lot of you realize we can restrict the answer to be x is greater than or equal to 1 of the original function. And so that its inverse would be. And so we could write.
Why are you only using 1/2 of?
Sorry?
Why are you only using 1/2 of the original?
Yeah, so there's another answer to this, but hold on. So the inverse for that is plus 1/2 x, what is it, plus 4, plus 1? Everyone see that? However, there is another answer, and you don't have to give me another answer, but you could definitely do it this way. A lot of you realize we could do x is less or equal to 1. What would that correspond to? That would correspond to this green part, I don't know if you can see it, of the original function. But obviously going less than 1, right? And so less than 1 would correspond to that yellow part. And I'll just do it here if that's okay. That's the negative one. So if we reflect that orange one, a lot of you realize the range would be, the inverse would be negative square root of 1/2 x plus 4. But combining the two, or if we had an overlap around 1, it would not be a function. For example, if we went from, let's say, less than 2, if we went less than 2, it would be this portion. From less than 2, it would be from this part here. And that would correspond to this, and I'll just draw it over here. If x was less than or equal to 2, it would correspond to this portion. It would look like that. And although this part is a function, right about here, it's not a function. Everyone see what I'm trying to do? So we're trying to restrict the domain at the optimal point, or the most likely answer, where it would be true. It would make its inverse a function. Virgie, you have a question?
Just like, where did what are you restricting for?
Of the original function, not of the transformation, but of the original thing.
Oh, okay.
Always that's the hard part for a lot of students. Most students think like a lot of you are going to cheat a little bit. What is obviously the interesting part is the vertex. It's really, the answer lies around the vertex. So when we transform that, that's going to be that point here. And that's why you're seeing it, as soon as you start drawing this plus or minus portion, like if you were to draw it, which it's still a relation, you can still graph it. I'm just saying to you, it's not a function, right? It's a relation. So what I'm trying to say is can we make its inverse a function? And the only way that we can do that, that's why a lot of students think, why don't we restrict it for the inverse? We don't restrict the inverse, we always restrict the original.
Okay.
Right? So,
I'm good with that.
this one?
Yeah.
So if I restricted the domain, let's say x is less than or equal to 2, x is less than or equal to 2 for the original, and 2 is right here. And it corresponds to what I'm going to be tracing with my finger. It goes this way, right?
Okay.
That's less than 2, right?
If it was that way, wouldn't that be like?
Sorry?
If you're talking about the one on the left, wouldn't that be like that root function that we're doing coordinate?
Oh, sorry, you were correct. Sorry, it should be that. You're right. Sorry, it should be this way. I drew it wrong.
Yeah.
So it should be this one. You're right. Sorry, I meant good. So it should have been this one. Absolutely. But this is not a function, anyways, right? Sorry, you're correct. It should have been the yellow one and the green. Nice. Everyone okay with that? So restricting the domain, it seems such a hard concept, but a lot of you are gonna cheat a little bit because you're gonna look at the vertex. So for example, let's just give you one final question, I'll make this one up. And this time, notice I'm gonna give it to you visually. Is that okay? And which one I'm gonna give you? I'm gonna give you this one, that's really easy, I think. This is obviously an absolute value question. Can I get a volunteer? Restrict the domain of this function so that its inverse will be a function. Any volunteer want to just give it to me? And it's, even though it's an absolute value, can anyone do it? What would be the restriction for this one? There's two possible answers, but there's actually an infinite number of answers, but there's an optimal answer. Flora, do you want to get it?
Domain either bigger than, greater or equal to 4, or domain smaller than 3.
It's correct. That's why we tend to focus only on domain. And again, to draw this, a lot of you realize this point is 4, -3. So 4, -3, if we were to do the inverse of this, that'd be -3 and 4. It'd be over here. And I apologize, I don't mean to do, I'm just making them up. I should do something different. But this is gonna look, this side is gonna look, this side's gonna be this one. And this one's gonna be that, right? And again, if you tilt your head sideways, and I apologize, if you tilt your head sideways, it's supposed to be a reflection across this y equals x. And the orange and red is not a function, right? It's not a function. But if we restrict the domain for this one, x is greater or equal to 4, and we just get that part. Want to see that? So a lot of you are cheating, and it's good. It's a good cheat. It's a good trick. That's the interesting part that's going to correspond to this. And this portion, greater than 4, corresponds to this part, which is greater than -4. Grace.
So how do we know what to restrict the domain by?
So technically, notice you could have gone, technically the answer could have been x is greater than or equal to 5, x is greater than 6, x is greater than 7. If we did x is greater than 5, right? At 5, that's probably what you'd see. And that's still a function, right? This part. Make sense? So the answer to your question is we're always kind of looking at I'll say it, the turning point, which is the vertex, which is why you're slowly connecting that the vertex, or where your eye tends to, like a lot of you are looking at this part of the absolute value. What the hell's that? Who cares? Oh, right here at 4 and -3, right? That's why it's interesting. You want to see what's going to happen there. Bridget.
So it doesn't matter which one of those.
That is correct. That's what I'm trying to share with you is that it's inverse for this absolute value. It's not a function, right? So to lead you, unlike the straight line that we did, like I want to restrict the domain so that its inverse is a function.
Okay.
Right? So I encourage you at home or now in class, you know all the base functions. We've already done parabolas and straight lines. So maybe sketch for yourself y equals x cubed and its inverse. We already did you might want to do the absolute value one again, just to check. Just sketch in. Don't get me wrong, there may or may not be functions. But you should be able to do the inverses. And then of course y equals 1 over x. Okay, so those are the last three you have to kind of figure out. Notice I didn't do the root function, because the root function, what do you do? I think you already know what that is. Its inverse is going to be, let's try. So this is the root function. Any volunteer want to tell me what's the inverse of this is going to look like? Yeah?
Quadratic or quadratic.
But not completely, right? So let's do the table of values for this. 0, 1, 4. So it's gonna look like this, right? The inverse is gonna be this. It's not a problem. But it is a function. Right? You're only seeing the positive side. Nice.